Hello, and welcome to an episode where we're going to uncover the bumps in the road for developers as organizations push harder on AI, real time analytics, and cloud native development. One of the biggest challenges they're running into isn't models and frameworks or even Kubernetes itself, it's data pipelines. Kubernetes has become the default control plane for modern applications, but data hasn't evolved at the same pace. What we see instead is growing sprawl of loosely connected services, storage over here, streaming platforms over there, metadata catalogs somewhere else, separate systems of governance, vectors, and observability. Individually, each of these tools does a good job. Collectively, they introduce friction. Teams spend more time stitching systems together, reconciling metadata, managing access controls, and debugging brittle pipelines than they do delivering the new capabilities to the business. Our research shows that it isn't an edge case, it's the norm. Most enterprises are running multiple data platform vendors, yet struggling with data quality silos and ability to scale AI workloads with confidence. That disconnectedness tells us something important. Integration on paper doesn't always translate into integration in practice. And as AI pipelines become more real time and more autonomous, whether it's streaming ingestion, RAG workflows, or agent driven execution, the pressure only increases. Metadata stops being descriptive and becomes operational. Streaming data isn't just transient, it needs governance, lineage, and replayability. Pipelines can't be fragile and glued together anymore. They have to be part of the platform itself. The desired outcome is clear: faster time to value for developers, fewer operational seams for platform teams, and data pipelines that can scale AI responsibly, adding more tools, more copies of data, and more risk if it's not addressed properly. In this video, we're going to unpack why streaming and metadata have become the bottlenecks in Kubernetes native environments and what architectural shifts are emerging to address them. Joining me today to help me unpack this is Andy Pernsteiner, who's the field CTO of Vast Data. Welcome on board, Andy.
Thanks for having me, Rob. It's great to be here.
Yeah, I mean, you're the perfect person to be talking to about this. I think that, Andy, as streaming often treated as a separate infrastructure rather than a first class data citizen, I guess you could say, based on your experience with customers, what actually changes for development teams when streaming events live naturally or natively within a data platform rather than alongside it and bolt on?
Well, I think that there's a few different aspects I think that change. Ultimately, developers they need all the tools at their fingertips. They need to have all of the infrastructure ready for them to use. And when you have disparate systems for streaming data versus long-term data versus the processing platform versus all the other bits and pieces, it just increases the amount of time it takes for a developer to become useful. If they need an environment, it means there's that many more pieces that need to be assembled. And oftentimes, the platform that is used for streaming and the platform that is used for longer term data for analysis, not only are they different platforms, but they're oftentimes managed by different teams. And so if you think about the bureaucracies that we live in, oftentimes that means filing separate tickets to go and have someone provision something. And oftentimes, because those things are done sort of asynchronously, the developer is waiting and they're waiting on one team or another. And it becomes one of those games that they have to play to try and figure out the fastest way to get what they need. So the first thing, when you have a unified platform that can deliver both sort of the real-time data as well as the analytical and longer term store, you don't have the same sort of friction in terms of getting things set up initially. But another aspect of it is that oftentimes, if I'm a developer and I need to interact with, let's say, a Kafka broker, and I have to also interact with an S3 object store, and I have to interact with another type of store like a database table, oftentimes I need three separate modes of authentication for those to be able to work together. Or I'm managing it in my own way somehow. Or I have yet another layer of software that I need to interact with that will give me the secrets I need for each one of these disparate systems. And so again, there's friction that gets in the way. It takes takes longer for me to get sort of useful use out of all the different systems that I want to interact with. If you have it all on the same platform, then you can work with a unified security model. So there's one access token that I need for all of the different pieces that are available to me, whether it be to be able to create and update database tables, whether it be to create or update topics for streaming data in and out of, whether it be able to create or update pipelines and functions that can process that data. If I have a unified platform that houses them all, then a single set of credentials is enough for me to get started, and oftentimes it's very easy for developers to get started in this way with their own sandbox without having to go and assemble all these pieces together. Now, that's when I think about what the developer experience needs to look like, it's always about a friction-free approach to getting an environment ready and being able to start iterating quickly. That's kind of the bottleneck oftentimes. And so, people might talk a lot about performance, they might talk a lot about agility, but a lot of agility and performance comes down to how quickly can I get started. That's the first thing. The second thing is that because now I have a unified authorization authentication model, not only can I get started quickly, but it's also easy for me to bring that into production because all of the controls are in place to allow it to do so, right? I can have a pipeline as well as a set of streaming events and database tables that are in a dev or staging environment. But then with the flip of a few switches, it's easy to transition that into production and ensure that it's authenticated and authorized in the correct way. And so being able to roll things into production quickly is another form of agility. But doing so safely is hard. And doing so safely is even harder when you have lots of different systems that you have to interact with. So having one makes it so much easier to do so. And then, honestly, at some point, there is fatigue in terms of learning different SDKs, API, authentication, authorization methods. And when developers have to learn lots of different frameworks just to get started and to work on a project, it does impede their ability to make progress. And so, again, having a single platform gives them a single place where they can start to work with the SDKs and APIs that are there and not have to worry about, sort of bringing in a new application or new product because everything can sort of live within the same framework and they can just iterate more quickly. So that's kind of where I think of from the developer experience. I mean, there's other parts of it, right? So the development teams themselves get faster agility when it's a single platform, but then you have to also think about all the operational teams that have a much more simplified approach to doing this, and so it makes it a lot easier for them as a, let's say, a DevOps or an AI ops or ML ops team to enable developers to be able to be active more quickly because they have a much simpler framework to work from where they can expose all the things that someone needs. Someone can ask for a database table, they can ask for Kubernetes storage, they can ask for an S3 bucket, they can ask for a vector store, and they can ask for a compute engine and an event stream without having to go and spin up separate systems. They can put it all underneath the same sort of identity and authorization model so that I can allocate it to those developers more easily. So that's sort of that's the beauty of tying all these things together.
Yeah, and it totally helps to them ship the code in a faster manner, in a more quality manner as well. Like you said, if there's less moving parts, there's less things that can go wrong. One of the other things is, a recurring theme is that metadata breaks down at scale because it's descriptive, it's not operational. And, in our study, 65% of organizations identified scaling AI as a primary challenge for their data platform teams. Can you walk us through an example where unifying metadata, audit logs, pipeline telemetry really removed an entire class of work for a platform team?
Yeah, I think that there's a few different aspects here. Obviously, the logging and the telemetry, that's important to understand whether you need to scale a pipeline up, whether you need to sort of replicate it to other environments, whether you understand if it's meeting its SLAs. But then on the metadata side, a lot of times the metadata about the data that's being analyzed and having derivatives built upon it, it's almost just as important or more important than the data itself. Oftentimes we work with a lot of clients who are doing model training as well as sort of fine tuning. And oftentimes generating the labels for all of the data is more time consuming than doing the actual work that they need to do. Because ultimately, when data is labeled, oftentimes what's happening is they're trying to classify it and then identify whether they need to read that data later or use it as part of a model training run or fine tuning run. And so basically the labeling up front gets out of the way all the extra work that has to happen later. And when you don't have a system that is able to not only sort of store the data, but also the catalog for the metadata in a unified way that everybody can have access to, it makes it again more difficult to be able to scale these things. And sort of tying all these pieces together, you think about if you think about telemetry, audit logs, all of those other bits and pieces, most of the time that's up to the operations team to sort of understand and manage it. But once we released the data engine in our platform in our last release, we also realized that end user developers, people who are building pipelines, who are coming up with the sort of orchestration, they need access to that telemetry and logging as well because they're iterating. They want to know, did my function complete quickly? Am I using a model that's fast enough for the type of inference I'm trying to do? Am I running into a scaling bottleneck? Do I need to increase the concurrency of the pipeline that I've built to handle peaks and valleys? And so only leaving that to the ops team means that you have a bottleneck in terms of when a developer realizes something's not going fast enough, they don't have the immediate access into that telemetry. So exposing telemetry to end user developers is also a very great way of doing that. And the way that we've built the data engine into our platform is done in such a way that not only are the high level metrics available to the administrators and the developers, but also the low level tracing to understand what part of a pipeline is taking the longest, where it's getting stuck. All of that's available as logging and metrics that someone can see in a visual way so they can be able to self-diagnose any issues that they might have when they're building things out. And so, whether it's metadata or whether it's sort of metadata about the jobs that they're running, whether it's telemetry to be able to understand where things are getting stuck. Again, having a single place to look at it and having a unified SDK for accessing that data makes it so much simpler and much more trivial to debug.
Yeah. I can see that for a fact because I've been in that situation when I was at another company and building out a SaaS product that used data pipelines. And you started to look there and understand all of the different load balancers and all of the different pipelines coming in and where they were going. And like you said, trying to debug that is an enormous amount of skill goes into that. In fact, what we're seeing is many teams, say they want Kubernetes benefits without making developers become Kubernetes experts. In fact, 55% of respondents to our study identified skills shortage as a significant concern. Again, just building off of what you were talking about, how does defining pipelines and triggers at the vast platform layer really help change who owns what and where teams typically get stuck today?
So I think that the place that teams get stuck today largely depends on the type of organization. What we find at enterprise is that the developers are not necessarily as Kubernetes savvy, and there's usually a pretty thick wall in between the sort of DevOps team and the developer teams. That is changing because enterprises are realizing that the sort of walls between these groups causes friction. Whereas if we work with cloud first natives or AI first native organizations, they oftentimes have a much tighter loop between the developers and the DevOps staffing. But even so, ultimately, especially as you see sort of AI assisted coding become more and more normalized within organizations, the amount of time that you want an engineer or developer spending on learning infrastructure is less and less. You don't want them to have to think about it. And so for some organizations where they already have Kubernetes expertise, we can integrate the data engine with their existing frameworks and leverage Kubernetes to run all of our functions. The developers don't need to know anything about Kubernetes. They need to know how to write Python code, right? And so when they are thinking about what they want to build, they don't need to think as much about the infrastructure. It's very similar to the fact that they don't need to think about, oh, how am I going to get access to a bucket and how am I going to get access to persistent storage and how am I going to get access to compute? Everything's in one place so they can go and they can basically make a single request to their DevOps organization or potentially have a self-service ability to do so and get their own sandbox to be able to develop their application in without needing to understand how Kubernetes works, without having to look at, K9s and try and debug where their pods are stuck, without having to understand Knative eventing and all the bits and pieces that go along with it. Now, for organizations that already are well staffed in terms of having a DevOps or AI ops team that understands Kubernetes, then great. But for those that don't have that expertise, or oftentimes you even see within an enterprise that there might be a group that has Kubernetes expertise, but they aren't necessarily providing access to the entire development community within an enterprise. And so our goal is also to allow for developers and engineers throughout an organization who aren't only on the AI ops or ML ops side to also give them the same experience where they can build pipelines without having to go and figure out how to build the infrastructure themselves. Kubernetes is not the simplest thing in the world to deploy and manage and scale. And so our goal is to make it so that instead of having to worry about all of that infrastructure, you can just stand up a vast system and be able to have all of that either managed for you, or if you want to augment it with your own Kubernetes service, you can do so. But the developers don't need to touch it at all, right? A developer writes Python code, they build it. Once it's built and deployed into a vast system, it can be automatically included in pipelines and be able to get used right away. Nobody has to go and manually decide how things are going to run. They don't have to go and deploy anything straight on Kubernetes. They don't have to learn kubectl or anything like that. They can just push a function to a vast platform, and from there, everything can be scheduled using our SDK and our APIs.
Yeah, they can stick to Python and not have to go into YAML. That's a
Yeah.
wonderful thing, to put it mildly. And it's funny because, like, one our survey also showed that organizations really do prefer a best of breed approach, but they have pipeline sprawl, and that clearly is slowing down AI delivery. Where do you see customers drawing the line between architectural purity and operational realities of getting things done?
Well, I think that everybody, including ourselves, we oftentimes find ourselves in this place as well, where we think about, well, we understand what it's like to build something from an architectural purity standpoint, but there's also a time to market. And oftentimes, especially nowadays, the sort of concept of failing fast is still very relevant in many people's minds. You want to test something out before you go and spend the entire time that would take to go build it out perfectly. And so I think honestly, the iteration by end developers leads to much faster innovation. Now, it doesn't mean that production pipelines shouldn't go through rigorous control, that they shouldn't go through an architectural review board to make sure that they've answered the questions around security and scaling and resiliency and everything that goes along with it. But enabling developers and enabling even non-developers, right? Earlier I mentioned AI coding assistants. I think that there's a lot of people now who are able to build things in a prototype way very quickly, and ultimately the ideas that they have can help push organizations forward in terms of innovation. And stifling them by putting them behind too much process and control means that you probably miss out on a lot of those ideas. So to me, it always feels like you want to start out by prototyping something within a community of people that understand the problem set, meaning the people on the business side or the people who are trying to solve an actual problem. And then once it's identified that they have some kind of a prototype solution, then it's usually time to bring it forward to what we see in many cases is an AI operational excellence or AI center of excellence group within an organization that can review it and understand, what are the sort of high value things that people have been developing, and then if we wanted to scale them, how would we do so? So, I would say the developers need to iterate quickly, but then when it comes to deploying for in production at scale, there still needs to be some kind of a process to bring it in using the standards that an organization has.
Yeah, I agree. I think that to me makes total sense. And I think what we're also seeing is that, as organizations deploy RAG pipelines, more agentic workflows, and real time inference, it's really stress testing their data architectures. What breaks first in a fragmented stack? And why does unifying storage, streaming, metadata matter more as an AI systems become more autonomous?
Well, I think that obviously there's complexity when you have lots of different pieces talking to each other. If anything is stuck or is broken, it's going to impact the rest of the pipeline. So if you have a scaling issue on your streaming events platform, it's going to slow everything down. Your Knative events aren't going to fire. Any sort of telemetry coming in and out is going to get stuck, and the whole thing is going to slow down. Um, and so having a single way of unifying everything makes it simpler from a debuggability and then even from a scaling standpoint, because again, if you have a platform that can hold everything and you can scale it as you need to, it's not just that you have to scale one thing or another. You can scale everything in concert if you choose to do so. Now in terms of sort of the scaling of everything else, like in terms of we talk to clients all the time who are looking at scaling their vector space into billions and trillions of vectors in a single instance. And what they've done historically is they basically spin up either open source or paid for vector stores, and they have to split it and shard it across many, many, many different instances or tables, which leads to application sort of complexity. And then when an issue happens, like maybe one of the database instances is having a problem, it's not just that one that has a problem. Now all of a sudden, part of their entire vector space is not accessible, which can likely lead to incorrect results or the whole system breaking down. And so we've looked at making sure that anything that someone could put on our system can scale up to the order of magnitude that our system can scale in general, right? So from a storage standpoint, we can scale into exabytes, which is beyond what most people are in. So I understand that that's kind of a little bit outlandish for most people to think in that term. But we look at the rest of our data and metadata structures to make sure they can scale as well. Billions and trillions of vectors in a single store, instead of having to split and shard it across many different table spaces, is also a design that we've implemented. And so that way, no matter what happens with the AI pipelines that are being developed, they have a place that they can grow even exponentially without having to go and refactor everything to go re-architect and build in another platform or shard it and put the complexity on the developers. We want to make sure that anything that someone can put on our system can scale as well as or as large as the system itself can scale.
Yeah, I totally agree. I think again, when you start to look at it, I don't think exabytes is that big a deal from now when you talk about people are moving around petabytes and things of that nature. As we kind of sit here, if we zoom out from features and products, what do you think most teams are still getting wrong about data platforms for AI? And why does fixing that fundamentally change time to value for developers?
Wow, that's an interesting one. I mean, I think that so one thing that I notice, especially if you think about, let's say, enterprise RAG or whatever that evolves into, I think the biggest barrier for scaling that within most regulated enterprises, which a lot of enterprises are regulated in some way, um, is the lack of a security model that allows you to scale it beyond a proof of concept, right? If you start out, everybody can build a proof of concept. They can allocate some systems either in the cloud or on-prem, and they can go and spin up a vector store, a database. They can spin up all the compute frameworks they want, and they can get it to work. But then when it comes to scaling it beyond the sort of rack they put their little pilot POC in, the first thing that happens is they bring it to a review board who says, okay, well let's probe it for scaling, and they have to make sure that it'll scale. We mentioned scale a moment ago, and they probe it for security. Will this work for every one of the departments within an organization? Can we ensure that the right people have access to the right data and the wrong people don't have access to the wrong data? And they get stuck there because there isn't a unified way to do that yet. There isn't. We, of course, are working on these things with some of our partners, but from a customer standpoint, what they're building in the world of pilots and POCs is oftentimes a sandbox that isn't going to live beyond the walls of their POC environment. And so people are stuck in many ways. Ultimately, they might turn to SaaS providers to do that for them, and that is an option, but it can also be a quite expensive option, especially if you're talking about a lot of historical data that needs to be pushed through it. So I think that I don't know that people are getting it wrong, but I think they're also real. When a team is building a proof of concept for enterprise RAG or another sort of search sort of based AI initiative, when they're building it, they're thinking about the best way to get time to value or the best way to sort of embed the documents they're pushing in, the best way to get the best scoring. They're researching all these pieces, but if they don't research the security side of it and make sure they have that answer, then they'll never get beyond POC phase.
I love that. I think that is a fantastic place to leave it. I think security and scale go hand in hand, and I think they're definitely two of the bigger challenges. Thank you, Andy, for coming on board. I think this has been great, and I think there's been a lot of knowledge given out here today.
Thank you.
And thank you for watching this episode, and stay tuned for more on this topic from theCUBE, the leader in tech news and analysis.